Welcome all. Today we are going to discuss about surface tension, and the reference taken is The Elements of Properties of Matter by D.S. Mathur. The contents we are going to discuss are molecular theory of surface tension, surface energy, excess pressure in a liquid drop, factors affecting surface tension, and its applications. So what do you mean by surface tension? Surface tension is essentially a molecular phenomenon. Surface tension is a property of liquid by which the free surface of a liquid behaves like a stretched membrane. That is, when consider a molecule inside a liquid, we can see that it is attracted by the surrounding molecules. That is, it has upward force, downward force, and also the sideways. But while considering the molecules at the surface of a liquid, it is attracted by sideways and also downwards. There is no upward force. All over the liquid surface, there is a downward force, and this downward force make it into a surface of a stretched membrane. So, surface tension is a property of a liquid by which the free surface of a liquid behaves like a stretched membrane. So, coming to a proper definition, it is a general experience that a liquid in small quantity, free from any external force like that due to gravity, will assume the form of a spherical drop. So, while considering surface tension, the points that should remember in our mind are the surface tension is only about the molecular phenomenon and it is free from any external force, and due to this the surface of a liquid behaves like a stretched membrane and will always assumes the form of a spherical drop. So these are the pictures of examples of surface tension in our daily life. The first one is an example. It is a picture of a soap bubble. Second one is a liquid drop. And third, the insects are floating on the surface of a liquid. And the more examples are, if some mercury is poured on a clear glass plate, small drops are seen to be spherical, whereas the large ones are elliptical or cylindrical. This is due to surface tension. And also, when surface tension of oil is less than that of water, so that when it is sprayed it spread and forms a thin layer above water. This prevents mosquitoes to breed on the surface of oily water. The separation of oil and water is produced by the tension in the surface between dissimilar liquids. This property of surface tension is called interface surface tension. These are all just examples. Then now we are going to learn some new definitions that are required for the study of molecular theory of surface tension. The first one is adhesion and second is cohesion. So adhesion is the force of attraction between molecules of same body, and this property is called cohesion, and the definite shape and rigidity of a solid body is due to cohesion, and it is strongest in solids. That is cohesion. Cohesion is an attraction between the molecules of the same substance. So the water molecules have attraction between themselves. That is, for example, when we consider a beaker consisting of a liquid, the liquid say water, the water molecules, the similar water molecules have attraction by themselves. So cohesion is the force of attraction between the molecules of same body, and this property is called cohesion, and the definite shape and rigidity of a solid body is due to cohesion. And coming to adhesion, it is a force of attraction between molecules of different substance, and this force is called adhesive force, and this property is called adhesion. For example, a drop of water sticks to the surface of a glass due to adhesion. So the molecules of glass are different and that of water are different. So there is an attraction between water molecules and the glass molecules. So it is adhesion. And next is molecular range and sphere of influence. So what is called molecular range? The maximum distance up to which the force of cohesion between two molecules can act. So while considering a molecule in a liquid that can be on the surface or inside, so the molecule have always a sphere of influence. The molecule have a certain distance up to which the attraction is there, and beyond that limit there will be no attraction. So the maximum distance up to which the force of attraction between molecules are present are called molecular range. And next is sphere of influence. So sphere of influence is the same idea, that is when we draw a sphere around a molecule, considering molecule as the center with a radius equal to the molecular range, it is called sphere of influence. And within the sphere of influence, the molecule can attracted by the surrounding molecules. That is, within the sphere of influence, the force of cohesion or the force of attraction between the two molecules can present. These are all just definitions that are required to study the molecular theory of surface tension. So next we are going to learn about the molecular theory of surface tension. For that, we are considering a beaker consisting of liquid, and A, B, C, D are just molecules at different positions. A is a molecule inside the liquid, and B is near to free surface, and C is just on the free surface, and D is above the free surface. So to explain the molecular theory of surface tension, we are taking the kinetic theory of gases. So surface tension is only for liquids, right? But for explanation of surface tension, we are just extending the kinetic theory of gases to the case of liquids. So this point is very important. While we have an question like to write about molecular theory of surface tension, you first draw the figure with explanation of the position of the different molecules and also write about the theory. Then going to deep, we have to specifically introduce about each molecule. So while considering the A molecule, A. So these circles drawn here are sphere of influence. That is, the A molecule has a force of cohesion or attraction only in between these range, and B molecule has only attraction in this range, the sphere of influence. In this molecular range, B molecules have attraction force. So in the case of A molecule, the A molecule is attracted by all the sides, upward, sideways, and also downwards. It is attracted by all the sides. So there is cohesive force, but due to all the forces, the resultant force is zero. No resultant cohesive force. So if a body has no force, what happens to that body? If a body has zero force, that means the body cannot move. The velocity is actually zero. So here also the A molecule is attracted by all the sides by the surrounding molecules, the net force equal to 0. That means the body has very negligible thermal velocity. And coming to B molecule. What is the speciality of B molecule? B molecule is near to free surface of the liquid. So the upper half of the sphere contains fewer molecules, which is gas molecules, and the lower half are the water or the liquid molecules attracting downwards. And so there is a resultant downward force. Only few molecules are attracted upwards and the remaining liquid molecules are attracted downwards. So there is a resultant downward force acting on B. And coming to C molecule. See, there are liquid molecules in the entire lower half. In the entire lower half, there are liquid molecules, and thus the resultant force in this case is maximum. The upper half contains gas molecules, but the entire lower half contains liquid molecules and is totally attracted downwards. The downward force is maximum in this case, and this downward force exerted per unit area of a liquid surface is its internal, intrinsic or cohesion pressure. That is, we all know that pressure equal to force per unit area. So here in the case of C molecule, the downward force is maximum comparing to all other. So the downward force exerted per unit area of a liquid surface is called the cohesion pressure. And this pressure, the cohesion pressure, is represented by a term called A by V square, where V is actually the volume and A is a constant. And this cohesion pressure modifies the equation, and this term comes in the van der Waals gas equation. In van der Waals force equation, P plus A by V square into V minus B equal to RT, where A by V square is a cohesion term. Coming to D molecule. D molecule is totally on the free surface. So when the sphere of influence passes entirely out of the liquid surface, actually the D molecule is totally, completely outside the liquid. There is no downward force. The sphere of influence consisting only gas molecules. So there is no downward force on the molecule at all and is free to move. So while considering the molecules at different positions, we thus see that all over the surface of a liquid there is a downward pull due to attraction between the molecules. All over the surface there is a downward force, and this downward force by which the free surface acts like a stretched membrane, that is called surface tension. And here it comes the end of the molecular theory of surface tension. I hope you all understand about this. And next is surface energy. We will consider in the next sections. And today we have discussed about surface tension and examples of surface tension and what you mean by cohesive, adhesive force and sphere of influence, molecular range, and also the molecular theory of surface tension. Up to which still the molecular theory of surface tension is very important. You just note down the points, write a short note, and I hope you all understand, and we will see in the coming sessions. Thank you.